Making ionic compounds. So an ion is when an atom loses an electron or a couple electrons or gains a couple electrons to have a filled outer shell or a filled valence shell. And you may ask, well, where do these electrons go or where do they come from? Well, they come from another atom or two. So for instance, when I look at my periodic table, which I folded in half, lithium has an extra electron in its outer shell. So if it were to lose that electron, a different atom, like fluorine for instance, okay, it wants one more electron, okay? It wants to gain one electron and it becomes negatively charged. And you can see the charge up here in the periodic table. It's like 1 minus. So 1 minus means it needs one to have a filled outer shell. The 1 plus means it's losing an electron. And what's interesting is the periodic table tells you what's gaining and losing electrons. So in the first column here, it says 1 plus, 1 plus, 1 plus. So that means everything in the first column, it needs to lose one electron to have a filled outer shell. If I look at the second column, the alkaline earth metals, it says 2 plus, 2 plus, 2 plus, 2 plus, 2 plus, all the way down. That means everything in this column needs to lose 2 electrons to have a filled outer shell. And some of them are complicated. There's 2 possibilities. We're going to talk about that later. So it basically goes like 1, 2, 3. And if we look at the other side of the periodic table, now noble gases are neutral, so there's no plus or minus. But the halogens, it's 1 minus, 1 minus, 1 minus, 1 minus. If we go one more in, it's 2 minus, 2 minus, 2 minus. One more in, 3, 3, 3. And we're now at the point where this is 4. So if you look at this column, it's the same to gain 4 as to lose 4. So we're going to look at ionic compounds. And this year there's 2 kinds of compounds we're going to look at, ionic and molecular. So start with ionic. So an example of an ionic compound is NaCl. So sodium chloride is table salt. So you have to start listening to the everyday names and associating with the chemical names. This ionic compound is made when a large number of sodium and chloride ions join to form an ionic crystal. So your salts tend to be crystals. And what's happened is sodium, when I look at it here on the periodic table, has a +1. That means it's lost 1 electron. Chlorine is -1. That means it needs to gain an electron. So they react well together. One wants to lose an electron, the other one wants to gain an electron. And this is what sodium chloride or salt looks like under a microscope. So let's kind of look at what exactly is happening. So looking at one NaCl particle, we see that the ionic bond between the sodium cation and the chloride anion is formed by the transfer of an electron from the metal to the non-metal. So sodium here had 1 extra electron and chlorine was missing an electron. So what happens is this electron leaves and goes to here. And we see evidence of a chemical change actually taking place. First of all, sodium is an explosive metal. It's soft. You could not ingest it all. It would just blow up in your mouth. Chlorine is a poisonous gas. But when a chemical reaction takes place and we create sodium chloride, we end up with something that we use all the time. It's table salt. So it has completely new properties. And then when we look at, all right, now what's happened? Well, sodium is now happy. It has a filled outer shell. And chlorine is also happy. It has a filled outer shell as well. Another example of an ionic compound is aluminum chloride. So aluminum, when I look at my periodic table, it says +3. So +3 means that it needs to lose 3 electrons to have a filled outer shell. So +3 means I need to lose 3 electrons. Well, chlorine, get my periodic table back, is -1. So chlorine only needs 1 electron to gain 1 electron to have a filled outer shell. So 1 chlorine and 1 aluminum is not going to work. But if I had 3 of these, it would actually work. So I just want to look at this picture. So what's happening is this electron goes to 1 chlorine atom. This one goes to a different chlorine atom. This one goes to a 3rd chlorine atom. So 1 aluminum needs 3 chlorine atoms to actually have everyone happy with filled outer shells for a reaction to take place. If there's not enough chlorine, it's not going to happen. So we need 1 aluminum and 3 chlorines. Properties of ionic compounds. Ionic bonds are very strong, resulting in the following physical properties. So they tend to be very, very hard, but yet brittle. And if you think about a block of salt, I have a salt lamp, which I'm actually looking at right now. Okay, it's very, very hard, but I know if I hit it with a hammer, it's going to smash into lots of little pieces. It also has high melting points, and most ionic compounds are solid at room temperature. Ionic compounds also conduct electricity, and part of the reason they conduct electricity is because ionic compounds are formed when a metal and a non-metal react. And that's a big thing. So in your homework, there's a bunch of questions where they're saying, does this form an ionic compound? And what you need to look at is, did I have a metal reacting with a non-metal? So you need to look at your periodic table and say, and if I had one in one of the previous notes, and if not, just look one up on the computer when you're doing your homework. In order for something to be an ionic compound, okay, you have a metal which gives up an electron and a non-metal that gains an electron. So two things, we need a metal and a non-metal. And the reason for that is the metals give up electrons, the non-metals are gaining the electrons. So the properties, we said is hard, brittle, high melting point, and they also conduct electricity. Some ionic compounds are soluble in water, so that means they dissolve in water. When ionic compounds dissolve, they produce a solution that conducts electricity. Such substances are known as electrolytes. So this was a lab that we did in grade 9, where if I put salt in the liquid, it will allow electrons to flow through and the light will light up. However, if I put sugar is all non-metals. That means it's not an ionic compound. It's a molecular compound. It does not conduct electricity. It will not actually light the light bulb up. So even though sugar and salt look very, very similar, actually they look exactly alike, the only thing different is the taste, one will conduct electricity because it's an ionic compound and the other will not.